Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So first thing I see is we're talking about even numbers. So how could we generally represent an even number? Let's say we've got n, and n could be any whole number. So 1, 2, 3, 4, so on and so on. So n could be even or it could be odd. Imagine I multiply it by 2. So we'd have 1 multiplied by 2, which is 2, 2 multiplied by 2, which is 4, 3 multiplied by 2, which is 6. And in general, any number multiplied by an even number is even. So n could be any number, we'll multiply it by 2, which is even. So overall, this is always going to be an even number. If this is an even number, what represents the next even number after that? Well, that's going to be 2n plus 2. So this is an even number. If we add 1, we've now got an odd number. Add 1 again, we get the next even number. Great, so now we've got that defined, we'll have a look back up at the question. So the sum, so that's a way of saying addition, and it's the sum of the squares. So we're going to take our first number, so 2n, I'm going to square it, and then we're going to add on our next number squared, so 2n plus 2 squared. So now I'm going to manipulate this and expand out the brackets and see what we get. When we've got a product in a bracket to a power like this, the power applies to each element. So we've got 2 to the power of 2 and n to the power of 2. Now we need to expand this bracket. So essentially what that is 2n plus 2 multiplied by 2n plus 2. And we've got to multiply every term by every other term. So I'll do the front term, so 2n multiplied by 2n gives us 4n squared. The outside term, so 2n multiplied by 2, giving us 4n. The inside terms, 2 multiplied by 2n, giving us 4n again. And 2 multiplied by 2, last but not least, giving us 4. If I simplify that down, I see that I've got 4n here and 4n here, so I can combine that. So we've got 4n squared plus 8n plus 4. We've got 2 to the power of 2, giving us 4n squared plus 4n squared plus 8n plus 4. See, now we can combine the n squared terms, giving us 8n squared plus 8n plus 4. Great, so we've expanded and we've simplified. So how do we prove that this is always a multiple of 4? Well, we need to factor out 4. And we see that 4 is actually a factor of each of the terms here. So if I take 4 outside the brackets, this term will be left with 2n squared, this term 2n, and this term 1. So this bracket could be anything, and because we said earlier that n is any whole number. But because we're multiplying by 4 here, we know that it's always going to be a multiple of 4. So we get 2 marks during our working out up here, and 1 mark down here for factoring out of 4, which completes our proof.